I am Yamasaka Kirian Dance. So I'm going to take you through a lesson in chemistry, where actually we're going to tackle a question in organic chemistry, particularly on esters. I hope you're going to enjoy the lesson. Actually, the first part of the question, it goes as follows. An ester can be made from the reaction of an alcohol and carboxylic acid. Write down the molecular formula and structural formula of ethanol and ethanoic acid. We actually start with for ethanol, which is actually alcohol. The general formula is actually CnH2n plus 1 and the hydroxyl group. Here N is equal to 2 because F always means that this F here means that there should be 2 carbon atoms in that compound. And so we are going to have C2H2 times 2 plus 1, and then you add the hydroxyl group. Then it gives us C2H, 2 times 2 is 4 plus 1, 5, with the hydroxyl group. And so this is the molecular formula. This is the molecular formula of ethanol. And now we look at the structural formula. The structural formula is actually gotten from the molecular formula. So you link, first of all, carbon to carbon with 1 bond. And the other carbon should be linked to the hydroxyl group. And then the remaining 5 hydrogen atoms, they should be around the carbon. And you notice that here, each carbon atom has 4 bonds around it, because each bond actually carries 2 electrons, meaning that there are now 8 electrons which are being shared here. And so this is the structural formula for actually ethanol, structural formula. So we have written the molecular formula as well as the structural formula for ethanol. Now we write the structural formula for ethanoic acid. So the general formula actually for organic acids is actually CnH2n plus 1, and you add the carboxylic group. And so here, N is equal to 1. Y is equal to 1 because we said F simply means that compound should contain 2 carbon atoms. There is already another carbon atom here. So there is no way we can put N is equal to 2 here, because we are going to have 3 carbon atoms. And therefore, what we are going to have is 1 there, 2 times 1 plus 1, and then the carboxylic group. So we are going to have one, you can omit it since it doesn't change anything. And here you have 2 times 1 plus 1, which is 3. And then the carboxylic group. So this is the molecular formula for ethanoic acid. And so, as we indicated earlier on, that actually the structure formula is gotten from the molecular formula. And you notice that here, again, we have 2 carbon atoms. So we link with a single bond, the 2 carbon atoms. And this is how we write the carboxylic group. The carboxylic group is actually written, this carboxylic group here. You have to write the carbon and 2 bonds to oxygen, and then carboxy group linked to actually to carbon. So the hydroxy group, and therefore for us to complete the structure, we are remaining with actually 3 atoms of hydrogen, which we can put there. And so this is actually the structural formula. For actually ethanoic acid. Right, the chemical structure reaction between ethanol and ethanoic acid. In other words, what they want us here is to write a chemical reaction between ethanol and ethanoic acid, but using structural diagrams. And as we saw, the structural formula for ethanol is as follows. We have the hydroxyl group. Then here we had hydrogen, and there hydrogen, and there hydrogen, and there hydrogen. This is ethanol. As we wrote the structural diagram for ethanol before. Then they are saying there should be a reaction with the ethanoic acid. And you remember, ethanoic acid, we wrote carbon, and this is linked to actually the hydroxyl group. This is hydroxyl group. So all of this is actually the carboxylic group. So we link that one. So this is how actually we wrote the structural diagram for ethanoic acid. This was the diagram, and we note that to every carbon atom, there should be 4 atoms. 1, 2, 3, 4. Even here, 1, 2, 3, 4. And so what do you produce? Actually, a reaction between ethanol and ethanoic acid is a condensation reaction. What do we mean by condensation? It means that we have to remove water. So there is removing of water. So how is this done? This is done by actually from the alcohol, you remove hydrogen, and from the acid, ethanoic acid, you remove the hydroxy group. So you remove this one, and here you remove that one, which forms actually, so this one carbon atom here, so you remove hydrogen from the alcohol and you remove the hydroxy group from ethanoic acid. In other words, what you have removed is actually, you have removed water. It means that you have removed water. And so here what we are remaining now is that the carbon atom from the alcohol, which is ethanol, will be linked to the oxygen, and the oxygen will be linked actually to this carbon atom. So what you are going to have is that we had our alcohol, hydrogen, hydrogen, here there is hydrogen, and there is hydrogen, and there is hydrogen. But remember, here we removed actually the hydrogen from the alcohol. So meaning that this oxygen should be linked to where we have removed actually the hydroxyl group in ethanoic acid. In other words, so we have our oxygen here, and this will be linked to that one there, and this will be linked to hydrogen. And as we said, this is hydrogen, and this is the hydrogen. There should be 4 atoms. So what we have done is that we have linked this oxygen from ethanol to actually to replace and rejoined it actually to the carbon from the carboxylic acid because we have removed actually, it's no longer carboxylic because we have removed actually the OH here. And so I've merely rearranged, I brought this one this side. And so, plus also the water that actually we removed. Remember, we removed the water. So we are going to have here water, which we removed. And here we have this compound, which is known as ethyl ethanoate. Ethanoate. And this is an ester. Ethyl ethanoate is actually an ester. Why is it an ester? Because it has an ester linkage. So the ester linkage is this one here. Okay. So here we had hydrogen. Okay. So this is the ester linkage here. So the ester linkage is actually wherever you find a compound which is actually like that. This is an ester linkage. And you note that in this compound, we have this linkage, which is here, which has been formed. And therefore, that's why I said ethyl ethanoate is an ester. I hope this has been fully explained. In brief, what I've said is that when you are reacting an alcohol and an organic acid, in this case, we had ethanol, reacting with the ethanoic acid, you remove from the ethanoic acid, you remove OH, and from the alcohol, you remove H, and join these together. So in other words, what you have removed is actually water, and this process is known as condensation, polymerization, meaning you are removing actually water. And so we go to another question. Is terylene a synthetic or natural macromolecule? Natural macromolecules actually are naturally existing. They are not made by actually man, while synthetic molecules are those that are made by man. But terylene actually is a synthetic molecule. Therefore, we are saying terylene is a synthetic macromolecule, meaning a big molecule, macromolecule. So terylene is a synthetic macromolecule. That one is done. Number D, terylene is a polyester used to make clothing material. Draw part of the structure of terylene chain using 3 monomer units. So what are monomer units? The monomer units are the ones actually you join together to form actually a polymer. So if you have a monomer plus another monomer plus so many monomers, so what you are going to produce is actually a polymer, meaning many monomers have been joined together to form actually a polymer. And so this is how actually terylene is formed. And it means that it has got a lot of esters. Poly means many. It means that the terylene, why it is called a polyester, because it has many actually esters, meaning the ester linkages that you remember we formed here. So there will be several of them, and therefore it is known as a polyester. And so this is a synthetic actually material that we use actually to make clothing material. And so they want us to draw actually the structure of terylene. I'll briefly explain how actually terylene is formed. It is formed from actually 2 monomers. It is formed from a monomer from organic acids and from an alcohol. As we saw when we are forming ethyl ethanoate, which is an ester, we use an organic acid and actually alcohol. You remember, if we go back here, we had ethanoic acid, which is an organic acid, plus ethanol, which is an alcohol. So we added them together to form actually ethyl ethanoate, which is an ester. So we expect an ester linkage here. And therefore, for example, if you have an alcohol with this linkage, and then you have the alcohol with the OH, which is the hydroxyl group. Again, you have repeating themselves you have an ester, you have actually an alcohol, again you have actually an alcohol, and so this process of actually making terylene, it uses also condensation polymerization, where actually you remove water, and so you remove the hydroxyl group from the acid, and you remove the hydrogen from the alcohol. So in other words, you are going to remove this one here, and this is actually water. You are removing. Again here, you are going to remove hydrogen from the alcohol and hydroxyl group. So you are removing water here. Similarly here, you are going to remove this one, meaning you are removing actually water. And this process is known as condensation polymerization. And so now what we are going to do now, it means that you have to join after we removed the water. We are going to join. We had this one here connected now to the oxygen which remained. Again, here we have oxygen connected to this compound. And there you have this one connected to oxygen, which is connected actually to that one. And therefore, this is actually the terylene or the polyester, which is formed actually as a result of the removal of water from the monomers. And so you notice that here you have actually several of these ester linkages, and that's why it is known as actually a polyester. You have that one there, you have another one there. So we have several of these, and therefore terylene is known as a polyester. And this is actually how actually terylene is formed from the monomer units. So this is how terylene is formed from the monomer units. The monomer units, which are actually from an organic acid as well as alcohol. And you may remove water, which is known as the condensation polymerization process, where you're removing water and you form now the structure of actually terylene, which is a polyester. So state one natural macromolecule which contains an ester linkage. Actually, these are the fats. The fats actually contain an ester linkage. So today I thought we can look at a question on the actually ester, and therefore we now see the exercise which have been given here. A few ethanoate is formed by the reaction of ethanol and ethanoic acid. Write the chemical reaction between ethanol and ethanoic acid using molecular formulas. You remember what we used there was actually the structure diagram. So now I want you to write actually that chemical reaction using the chemical formulas. And the second part of the question is that fats and lipids are formed by condensation polymerization of fatty acids and glycerol. Write the chemical reaction using structure diagram for glycerol and fatty acids to form fats. So in other words, you are going to react glycerol and fatty acids, and then you form actually fats. So for answers, actually, you can contact me on the ksyamasaka@gmail.com and the WhatsApp number +2609774199949. However, the exercise is not free because I have to spare some time. I can actually give you the answers through an explanation, or I can just write the answers and you will read for yourself. But you just have to pay a small token. I thank you.